This is the attachment missile, essentially. A solid fuel rocket propulsion system. Missiles ascend post-launch using GPS. Or course adjustment, their fins move. Per visuals directed by inertial. Navigation or military-grade GPS to hit designated targets upon impact. The sensor triggers a 500-pound TNT blast, capable of bunker destruction. Interestingly, these missiles can operate from both the HIMARS with a single pod launcher and the track version of MLRS platform with dual launcher mode. Transportation of this system necessitates a platform like this Galaxy C5 aircraft, so stay tuned as we delve into the step-by-step process of how this operates, and don't miss a comma beat. Let's start from the front. This is the impact sensor, and just behind it is the improved missile guidance system. It can use both inertial guidance as well as global positioning system. GPS relies on a network of satellites and orbit around the Earth. The GPS receivers on the ground or in vehicles calculate their position by triangulating signals from multiple satellites. It provides highly accurate position information as long as there is a clear line of sight to a sufficient number of satellites, while IMS uses onboard sensors to track changes in speed and direction, determining its position by adding up these measurements from a known starting point. It works without needing external signals and can navigate even when GPS signals are blocked, like in tunnels or cities with tall buildings. Moving to the back is the weapon system, not just any warhead. It can be interchangeable with this bomb that stacks a staggering cluster munition dispensing models, loaded with 950 and 275 to 300 some munitions, and the other warhead is this unitary weapon. The warhead is known as the WD-18 and produces a blast equivalent to 500 pounds of TNT. Just behind it is the GPS antenna. Moving further back, we have the motor as well as the rocket fuel. At the back are the fins that help steer the missile towards its designated target. Let's delve into the mechanics of how a solid rocket functions through some straightforward animations. The top of the rocket is the electrical ignition. When ignited, initiates the combustion process of the solid propellant. This propellant is not just any substance. It's a precise mixture of fuel and oxidizer, carefully poured into a case and then cured. Surrounding this mixture is a protective covering known as a motor case. This motor case plays a crucial role as it acts as a robust pressure vessel containing the intense forces generated within the combustion chamber within the core of the rocket, precisely where all the pressure is concentrated, lies the propellant burning zone. This is the heart of the rocket propulsion system, as the solid fuel and oxidizer react and burn within this zone. They generate extremely high temperature combustion gases to harness this energy. The combustion gases are channeled through a nozzle. This nozzle is designed to accelerate the flow of gases and direct them out of the rocket's rear end. It's in this very moment that the rocket's propulsion system comes to life. The high-speed expulsion of these combustion gases generates an equal and opposite force in the opposite direction. Following Newton's third law, motion, this force is what we call thrust, and it's a driving force that propels the rocket forward, allowing it to overcome gravity and achieve its mission. This compact solid fuel rocket reaches a mind-blowing Mach 3 speed equaling 2,300, and a plane, an astounding advancement in rocket tech with broad applications. Comparatively, the French and British Storm Shadow missiles operate at a modest 600 miles per hour, dwarfed by the smaller solid fuel rocket's four-fold faster Mach 3 speed. Even the renowned Russian Kh-101 missile reaches just 583 mph, emphasizing the rocket's exceptional velocity. The attack's missiles have a length of 13 feet, or approximately 4 m, with a diameter of 24 inches or 610 millimeters. Comparing this to a person will help us understand its size even better. Let's compare this to its counterparts like the Iskander missile or the Kennel missile, animated in our recent videos. Here is the famous Storm Shadow from France and Britain, which is air launch, and just beside the Russian K-101 missiles. This bad boy can weigh staggering up to 560 kilograms, considering it can hold 930 mil-74 bomblets. This missile was designed to operate from two platforms, HIMARS and MLRS. HIMARS carries one missile pod, whereas the M270 carries a two-section pods. HIMARS is a lighter version of the M270. This MLRS is equipped with track wheels and is much heavier, but has the ability to go off-road. The MLR is operated by a crew of 3, a driver, a gunner, and a commander. However, the computer-based fire control system enables a crew of 2 or even a single soldier to load and unload the system. Let's explore the basic tactics and maneuvers involved in launching this missile. Step 1. The Lockheed C-5 Galaxy aircraft transports the MLS to a designated safe location. Once loaded, it can be rolled on and off this aircraft and becomes operational within 15 minutes of landing. Step 2. The crew unloads the MLRS along with the reloader, and Step 3. The battalion travels nearly 70 kilometers or 40 miles closer to the front lines. Step 4. The control and command center designate targets to be destroyed. Step 5. In high threat situations, the MLRS utilizes a shoot and scoop capability to enhance crew and platform survivability. The NLR has capacity to deploy, shoot, move, and reload within minutes, significantly impedes an enemy's ability to locate and target the firing platform. Step 6. The MLRs and HIMARS conduct reload operations using a reload arm assembly to reload missiles. Step 7. The fins inside the pod are always folded upon launch. They unfold to stabilize its path. As mentioned earlier, a missile can feature multiple guidance systems and may switch between them during its flight. For Instance, a long-range missile might ascend to a predetermined height to adjust its course using GPS shortly after launch. In short, this is how the fins works. They can move left or right. Just to show in the visuals, these control surfaces are dictated by the inertial navigation system or military grade GPS to turn the missiles to its designated target. Step 8. When it reaches its target, the impact sensor activates and triggers the warhead and produces a blast equivalent to 500 pounds of TNT, capable of damaging or destroying any bunker in that battlefield. Let's delve into is the Future Precision Strike Missile and how it works. These precision strike missiles, developed by Lockheed Martin, boast a length of 156 in and a diameter of 17 in, incorporating a new rocket motor for incentive munition high performance. The optimized warhead houses preformed fragments, contributing to the designation of this missile as a precision strike missile equipped with an advanced GS antenna. The intentional design of this available volume provides space for future expansion, accommodating additional warheads or tracking and targeting software when ready. HIMARS unit fires 2 missiles in rapid succession, heightening the element of surprise. 2 precision strike missiles are now en route to the designated targets. These missiles utilize GPS updates to ensure accuracy, navigating first to target number 2, the arming and refueling point, and then proceeding to the hostile SAM site identified as target number 1. The optimized warhead, utilizing pre-formed fragments, intensifies lethality and maximize his area effects. These fragments are meant to damage high-value target like this $1 billion S-400 missile system, animated in our recent video. We make original 4K 3D animation with a small team of animators, so please support us by subscribing and dropping in a comment for more exclusive engineering animations made just for you guys.